Hello, and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will do a couple of problems from section 8-sample size, where we're trying to find sample size. Here, we're trying to find a sample size based on the proportion. So in this particular problem, this is problem number 3. We are looking for problem number 3, we're looking for a candidate asking the poll determine the percentage of people to support her if the candidate only wants 10% margin of error and 95% confidence level. What is the sample size needed? When finding the z-value, round it to 4 decimal places, but your answer should be a whole number because it has to be n. So for us, we will just go directly into Google Sheets and we will not have to do any rounding off. And so we don't need to worry too much about this rounding off to 4 decimal places business because we'll just take it from there. All right, the formula that we will need for this particular problem is our n formula. So n, and if you remember, this is going to be equal to z sub alpha over 2 times or z sub alpha of 2 squared times p hat times q hat, all divided by the error bound for the proportion, also quantity squared. And this was derived from the EBP formula, where instead of EBP is equal to something, we solve for n, and then eventually get n is equal to this set of formulas. Now, one thing to note here is that we are interested in finding p hat, q hat, if there was a previous study or some sort of approximation of what p hat and q hat are equal to. So if no p hat is given, assume p hat is equal to 0.5. And what that does is that it gives the largest amount of combination between p hat and q hat when you multiply them together. And so just to be safe with our particular study, the larger the n is, the safer we are with finding our most accurate statistics. So if there's no p hat given, then we'll use 0.5. All right, let's bring out our Google Sheets. And here we have some information about, or I have kind of a template set up, our p hat and q hat. So again, if there's no p hat given, we'll assume it's equal to 0.5. All right, and then q hat is going to be equal to 1 minus the p hat value, so 1 minus, and then I'll click on this cell that gives me 0.5, which I already knew that, but for future references, when if you get this set up, if you put these as formulas, then it'll make it easier to do the computation for us later. So the error bound is the margin of error essentially, and here it's given us 10%. So we can say this is given as 0.10, 10%, 0.10, or however you want to put that. Now we want the z sub alpha based on the confidence level. So maybe before we get z sub alpha here, let's figure out what alpha is. So let's say alpha is equal to the complement of 95, so that's 0.05. So that's what alpha is. And then now I can use this 0.05 as a reference to figure out my z sub alpha over 2. So z sub alpha over 2, if you remember, is going to be a norm.inv command. And then the x value is not alpha, but alpha over 2. So I'll click on that alpha and I'll divide it by 2. And then this is coming from the standard normal distribution that has a mean of 0 and a standard deviation of 1. And I'll hit close parentheses and enter. I see I get a negative number. Now, in this particular scenario, it doesn't really matter if it's negative because you're going to square that anyways. But just to be really safe, I'm going to click back at this cell. I'm going to click back at this option over here where now I can edit this, and I'll squeeze in a minus sign. And then I'll press enter and I'll see I get a positive number now. So that it's 1.96, which is that popular Z Z critical value that we've seen before. All right, now let's put in the formula for the sample size n. So maybe I'll put n here, n, and then is equal to, and then I'll do this n computation in this cell. So I'll say equals, and then I have z sub alpha squared. So I'll start off with that. I'll click on this, and then I'll use the caret, that command or shift 6, and then I'll square that. So that's the first component. Now I need to put a times, and then the p hat is given here, and then times the q hat, and then I will divide this by the EBP, the error bound for the mean, and then I need to square that, so EBP squared. Now the way it's written here, we don't need parentheses because of the order of operations. It'll take care of the exponents first, and then it'll do the multiplication and division in order from left to right. So this will be computed as is, and then we should get the correct answer, and we don't have to worry about parentheses. If you are worried about parentheses, you can definitely put parentheses around where you think it might be appropriate. But adding more parentheses in something that already works should not hurt your problem unless you put the parentheses in the wrong places. But in this case, it should be okay. So I'll press enter, and I get 96.03. Now remember, you want a whole number here, so you're always going to want to round up. So it looks like you should round off to 96 as a whole number, but you always want to round up. So I'll write down n is equal to 96.036. So I'll temporarily put that here. N is equal to 96.06 or whatever it was. But remember that we want to round up to the nearest whole number. So n is actually equal to 97. Okay. Now, I wanted to do this next problem in the same video because there's a stark comparison here. Because in the first example, p hat was not given. So in this example, they give an approximation for the population proportion to be 0.35. So if we know that, then we can take advantage of using that and hopefully come up with a smaller size. Now, I'm looking ahead, and it says within 2% of the true population proportion versus 10% of margin of error. So margin of error, they want a small margin of error, so they want to be more precise with their approximation. So I have a feeling that this is going to be a larger sample size. But we'll have our our Google Sheets work that out for us. So we'll look at this. Well, let's see. We have our given proportion in this particular problem, p is equal to 0.35. And so, and we'll need to change the critical z value, and we'll need to change the error bound, EBP, error bound for the proportion. Okay, so let's go ahead and do that here. Since we have this already set up, remember all we have to do is change the p hat, and then change the alpha, and then everything else should automatically change for us. So the p hat was 0.35. You can see that the q hat changed to 0.65. We also need to change the error bound for the proportion, now at 2%. So I need to change this to 2%, which translates to 0.02. And then our alpha is 0.04 because this is 96%. So we want to change this to 0.04. and then our alpha changed, our Q hat changed, and more importantly, we got a new sample size. Now this is a super large sample size, 2,398, where we always want to round up, so we'll just go ahead and say 30 or 2399. Okay, and so if you had the previous problem done, and then all you have to do is change a few things because everything else was typed in as a formula, then you get your formula at the end, and that is your sample size. So 2399. So our n, let's put this as our answer in red, n is equal to 2399. Okay, and that's it. So good luck with these problems, and I'll see you around.